Question 7 is about the different types of radiation. It says alpha particles, beta particles, and gamma rays. It says alpha particles, beta particles, and gamma rays are types of nuclear radiation. What does an alpha particle consist of? Now, this question is important, so you have to make sure you understand it before you write the answer. It doesn't ask you what is an alpha particle. It says what does an alpha particle consists of. This is what is important. If you remind yourself, alpha particle is helium nucleus with a mass of 4 and a charge of 2. Now, the top number here, this presents protons plus neutrons, whereas this is my protons only. So if I do 4 take away 2, it leaves me with 2, and these are my neutrons. So all I'll say in this case is I'll say it consists of 2 protons and 2 neutrons. Next part says a krypton nucleus decays into a rubidium Rb nucleus by emitting a beta particle. By emitting a beta particle, this is what the beta particle is. Complete the nuclear equation for this decay by writing the missing number in each box. It says decay. So whenever it's a nuclear decay, you have to remind yourself about two concepts. One is mass and the other one is charge. They are both conserved. Now this means the total mass before will be equal to total mass after, and same applies to the charge. Total charge before will be equal to after. So if I look at the left side of this arrow, left side is before and right side is after. So what's the total charge before? It is 36. What's the total charge on the right side? It should also be 36 when added together. So I've got -1 here. What number do I need to write here so that when I add them two numbers, they should give me charge of 36. The number will be 37. I will do the same thing for the top number. So I can see here, if I add 85 and 0, the total mass is 85 on the right side. So the total mass on the left side will also be 85. Next part says internal contamination of the human body means radioactive material is inside the human body. So they are basically describing what contamination means. So contamination means when radioactive material becomes part of your body. Explain how the risk from internal contamination is different to the risk from external irradiation by a source of alpha particles. Basically, you'll have to make two sections for this. First one will be about contamination, and the other one will be irradiation. Now remind yourself, contamination means when the source becomes part of your body. Irradiation means the source does not become part of your body, but your body is only exposed to the source, which is radioactive, for a short period of time. So I can say here source is inside, here I'll say source is outside. And based on this information, I'm going to now structure my answer. I'm going to say when it is inside, the main thing that I need to remember here is I can say alpha particles are highly ionizing. Number 2, because they are highly ionizing, what will happen? They will be absorbed by the tissues. Alpha particles will be absorbed by tissues. And if they get absorbed by the tissues and they're highly ionizing, this means energy will be delivered to the tissue. So we can then say risk of cancer will be very, very high. On the other side, we are talking about irradiation. So what will happen in this case, considering the same property that alpha particles are very ionizing, we'll say they will not reach the body. Number 1. But if they do reach the body, we can then say if they reach the body, they will be stopped by the skin. I can add one last bit to both sides, and that is here I'll say body will receive radiation for short time. In this case, I'll say body will receive radiation for long duration. Because here, once you move away from the source, your body will not receive radiation. But in this case, if the source has become part of your body, no matter where you are, your body will keep on receiving radiation.